Hey kids, this is Ivan. How you doing? Well, today I'm gonna try not to tick too many people off. I say that every once in a while. This really isn't controversial. It's not a controversial video at all. But you might not agree with what I'm going to say, and in which case you're wrong. So now that I preface it with that incredibly egotistical statement, I will say that I'm not a math expert by any means. However, I do know some probability and some statistics, and I know enough about them to know that they're very counterintuitive at times. So what happened, I guess yesterday, I'm looking at one of the groups I'm a member of, and I'm not even going to say which one, because really, when I say I don't want to get people upset, because hopefully nobody involved in the discussion gets ticked off, because that's not really my intent. But somebody mentioned something like, in the game they were in, somebody rolled something like 3 or 4 ones all at once on some d20s, and what are the probabilities of that happening? And so the discussion started about that. Maybe it was 3, whatever it was. But then the discussion started, and people started saying some things that were misconceptions. And the thing is, they don't even realize they're misconceptions because they're very common, and some things are a little bit more bizarre. So I just want to go over a little bit, and try not to be too pedantic, but to talk a little bit about, rolling dice and, why the order of rolling dice actually matters. It doesn't seem like it would, but it does. Here's first example. You do something like, what do you call it? The advantage-disadvantage mechanic in something like 5th edition D&D. So you got these 2 d20, right? Your chances of, say, rolling 11 or greater, if you roll both these at once on at least one of them, 75%. Okay, get it? However, and this is, I think, the first time I got in discussion with this lately with somebody, they were calling it a re-roll. And well, no, it's not actually a re-roll because the probabilities would be different at that point. They're like, oh, no, of course they wouldn't be. Well, here's the deal. No matter what number you roll on this first die, let's just say it's, not at least an 11, and you need at least an 11. If you want to re-roll second die, your chances of rolling an 11 or greater on this second die, 50%. You don't have a 75% chance anymore. The order matters. Another thing would be, let's say something like, we're going to roll 3d6. We're going to create ourselves a D&D character. What are my chances of rolling an 18? Well, if I roll them all at once, it's, what is that, 1 in 216 of getting an 18. Okay, all sixes. However, if I've already rolled a 6 on one die, and I'm going to roll a second die, what are my chances of getting a 12? Are they 1 in 36? No, they're 1 in 6. Now, let's just say I've got 2 6s at this point. I've got the third die, and I'll roll this separately. What are my chances of getting this guy up to 18, rolling a 6? 1 in 6. The order matters. The other interesting thing that somebody said in the discussion, and I know what they meant. Somebody else actually beat me to it, but they know what they meant. But they were talking about the idea that what happens in probability curves, you're flipping a coin like 100 times, So we'll go with a ubiquity die or something like that. I don't have one right next to me. But you got a coin. You're flipping it like 100 times. You're going to see clustering. You're going to see clusters of all heads, all tails. That's one of the ways you can tell if somebody made this random series up, or whether or not it's a real, true random series. Is if you don't see these kind of clusterings, it's a good chance that it's not, not impossible for it to go heads, tails, heads, tails, heads, tails, but it's very unlikely. Generally, you're going to see some clustering of all heads and all tails. But they mentioned that, well, yeah, what happens is when you roll a die or flip a coin, what happens with that die if you roll a 1 on the die the first time, or tails on the coin the first time, that's going to affect that next die, how that next die rolls, because they cluster. Really? And they just kind of misunderstood what was happening. So I guarantee you this, I've rolled this die many, many, many times. I haven't rolled this one as much because my daughter just got me this nifty red scarab set that I've been wanting for a while. However, I can tell you, chances of rolling a 6 on either one of them right now, 1 in 6. Doesn't matter how many times I've rolled this other die, 1 in 6 both times. Last but not least, I'll go with this. And if you don't believe me, go check all this stuff out. Not on a forum. Go check out some decent sites on mathematics and probability. To underscore, why you shouldn't feel bad and how bizarre this is, how non-counterintuitive it is, I give you the Monty Hall paradox. Not the Monty Hall like Monty H-A-U-L in Dungeons, but Monty Hall like the old, gosh, I forget the game show that he was in now. Let's Make a Deal. At some point during the show, there'll be 3 doors, and there's going to be a car behind one of those doors, and behind the other 2 doors, there's going to be like a goat, something you really don't want or need. And so for what happens is you choose door 1, 2, or 3. Which door do you want to choose first? Okay, you've got a 1 in 3 chance, 33.333 percent chance of choosing the car at that point. And then they eliminate one of the other doors. So now they tell you, okay, well, we've eliminated one of the goats. So now either the car is behind the door that you've already chosen, or it's behind the other door that you did not choose. Do you want to switch? Do you want to choose the other door? And so the question was posed to people, well, would the probability be any different? Is there any advantage to choosing the other door and switching your choice? And mathematics professors, all kinds of people said, no, of course not. The probabilities are the same. Actually, I think it's Marilyn Vos Savant had like a column at one point. Very, very intelligent person. I think she tested as one of the most intelligent person on the planet Earth at one point. I won't even go with what her intelligence was because I don't care. I don't buy into that sort of stuff in terms of equating it to ability scores. However, and she gave the correct answer, and people like wrote in from all over the place telling her she was wrong until they checked. Deal is you're better off changing, because at this point, if you change the doors, you now have a 1 in 2 chance. You have a 50% chance of getting it right. You have a higher chance of getting that car if you switch the door than if you did before. That seems to make no sense. Well, why would it be a higher possibility? But it is. The sequence matters. Check it out.